the derivative of natural log x is 1 over x. Okay, and the derivative of log of x is almost the same thing. So if you have a logarithm, it's like you put the argument in the bottom of a fraction, but if it's anything other than natural log, you need to take a natural log of the base. And remember, if you just write log of x, that's log base 10 of x. So that's where that 10 came from. It's a logarithm of the base. All right, so if we need to find a derivative, oh, sorry, prime there, derivative. Okay, if we need to find a derivative of natural log of x to the third, just don't forget the chain rule, but everything else is just like what I described up above. It's 1 over x to the third. That's the derivative of natural log, but then we need to multiply it by the derivative of the inside function. So the derivative is 3x squared. Right, and when you simplify that, you got x squared in the numerator, x to the third in the denominator, so you still have an x in the bottom, and we have a 3 that's in the numerator. So there's our derivative of natural log x to the third. Okay, so it's right here. I just did the algebra to simplify, right? Put a 1 under here, then you lose an x squared up top and an x squared on bottom, so it leaves you with 3 over x. Okay, let's do this one, log base 3 of x to the third. If I want that derivative, I really want that derivative. Can't go on with my scientific research without that derivative. It's just like what I described up above here. It's 1 over the argument, so 1 over x to the third. But if it's not a natural log, you need to multiply it by natural log of the base. So there's our derivative of the outermost function. But now, ignoring the log stuff and just focusing on this function, I need a derivative of x to the third. So that's 3x squared. So when you clean that up, the x squared and 2 of the x's down here cancel. Still get a 3 on top, so it's 3 over x natural log 3. So there's our derivative of that one.